Hi, everyone. All right, any questions over the homework? Carly. Sure. Actually, hold on one sec. Just while I'm here, in case people had this question, because several people first period had it, so I want to make sure it's an easy anyway. When you're doing limits of integration, and you don't go all the way to the axis of rotation necessarily. It's all about the shaded region. So like for 21, the limits of integration would not go from 0 to 4. It just goes from 0 to 2 because that's where the shaded region ended. So I just want to make sure we're clear on that. But you said, 12? 13. 11. I almost got there. 11. All right, so here's 11. Was there a particular part or just the whole thing? All right. So the region bounded by that. Now, I actually don't remember if that's exactly what the curve looked like or I made it up. Because this would be one of those, like, let's say that we don't know what it looks like and we don't get to use a calculator. Between x equals 0 and x equals 1. So x is going to be a positive number. Well, it turns out it actually doesn't matter on this one. Let me use this to point. 1 over 2 pi, that's always positive. And e to any power, always positive. So y is always positive. Always here. And then y equals 0, x equals 0, x equals 0, x equals 1. I know it's this region. So you can get a good enough picture without a calculator. But any questions just on that part? All right, and then it did say use shells. So if we're rotating about the y-axis, your rectangle will always be drawn parallel for shells, which makes this a dx problem. And then you got to find P and H. So remember, P is the radius of the shell. So P gets measured from the axis of rotation to the rectangle. And P is that weird one. Whether it's top minus bottom or right minus left, the two parts, one part is always just x or y, and the other part is whatever the axis of rotation is. In this case, right minus left, it's a dx problem, so x minus 0 is just x. And then h is the height of the rectangle. That will make the height of the shell. So top minus bottom is the function minus 0. So any questions finding P and H? Because then you plug in and you get this. So 2 pi ph dx or dy. And then this is when you can just use substitution. Remember when you got e to a power? Then try letting, for us right now, our strategy is if you see e to a power, and you don't know what to do, let u equal the power and see where it goes. And it turns out u substitution works out really nicely on this. Does anybody want more detail? All right, any other questions? Carly.
So going back to 21, I did have a question. How do you know what, I drew mine out a little bit more than you drew yours out, but how do you know what section to use? Because I didn't know if we used that first section, which was shaded, or the one that was pressed against the axis of rotation.
Well, the only region that's bounded by those two curves is the one that's drawn. If I highlight these two curves, and if you ignore the axes, because it doesn't say to use one of the axes. I need to go back to 21 now. So you have a parabola that opens up, and you have a parabola that opens down. And actually, I'll make it more like it was. There's only one place that's being bounded by those curves.
I'll show you what I'm talking about.
Yeah.
So I didn't know if I used this section or this section. Because the line.
Oh, doesn't say it's bounded by x.
Okay, gotcha.
Yeah, just so you know, it was a good question. So let me actually draw more so that, because I'm sure she's not the only one with it. Let me make these not so thick anymore. So when you draw it, you've got your one parabola opening up, you got your other parabola opening down, and then you have this, maybe not so far over. Oh, man. So, is it this region or is it this region? That's what, because when you draw the picture, it does kind of look like there'd be two regions. But when you look at the wording, I don't know if I copied the wording down right. Yeah. If you actually look at like the full wording, I kind of have it here though. It says that the region is only bounded by the parabolas, and then that region is rotated about the line. So this axis of rotation is not one of the boundaries. So yeah, good question. Any other questions? All right, let me have your homework then, please. Yay! Oh, good in the hood. Guess what? I have your celebrations of college. I didn't put them in Canvas yet. Oh, I'm scared now. Oh, I'm going to pause the recording. Pause. Don't let me forget to unpause it. All right. Yeah, March 10th. See, Mario? In case you didn't know. Happy Mario Day! Sorry, I gotta take a piece of graph paper. You can't. Can you reach it? Am I in the way? Okay. Review of volumes. Let's do it. So we've done cross sections, we've done discs, we've done washers, we've done shells. Let's put this all together and figure out when you use which one. Ha ha. Let's first look at cross sections because that's what we did first. Cross sections. Ooh. Oh, coloring. I don't like the way that looks. It looks stupid. All right. So, does anybody know, before I put any kind of example up here, how do you know when to use volume by cross sections? Nate? No. This one is almost too easy. Oh, now that I say that, you're like, is it? Could it? Malika? Yeah. The question is going to have to use the word cross sections in it. Problem mentions cross sections. Do you remember how to determine whether this is a dx or a dy problem? Sophia? You are correct. Yeah, so draw the rectangle, the representative rectangle. perpendicular to, wait, I kind of messed up the wording of this. Sorry. The problem will tell you which way to draw it. That's what I wanted to say. And I didn't start off by saying it. The problem will tell you if the cross section is perpendicular to the x-axis or y-axis. And so you draw the rectangle that way, and that tells you if it's a dx or dy problem. So let's put a picture now. I'll just put kind of a generic picture with no specific functions. Let's call this guy y equals f of x. Let's call this one down here y equals g of x. And let's just say the base of the solid will go from A to B. And just so we have an example to kind of latch onto, we'll say that the cross sections are perpendicular to the x-axis. And there's something very exciting. I'm going to say the cross sections are squares. So I'll make a square out of this just so I have something. Oh, that's a really, not too particular, but that was a horrible square. Anybody like the movie Pulp Fiction? It's one of my all-time favorite movies. So I don't know if you remember, there's a scene in the movie where Uma Thurman tells John Travolta's character, "Don't be such a," and then she draws out a square. Except she doesn't. She clearly draws a rectangle. Like, it's a very bad square. It always bugs me. Oh, always bugs me. And then, to make matters worse, hers actually wouldn't be, it wasn't too far off, but it's definitely not a square. But then, it was trying to be cute, so it follows her fingers with little dashed lines. Except the dashed lines make an even more stretched out rectangle. Like, they make it worse. They could have fixed her square and drawn a square, but no, they drew a rectangle. She's telling him, "Don't be such a rectangle." Oh, bugs me. Little things. I can let things go. That one I can't. Jeopardy. I was watching the College Jeopardy one time. This was years ago. They had a math question. And it wasn't even the $200 question. This was further down. I forget. It wasn't the $1,000 one, but I forget where it was. Anyway, it was a video question. And the video question was this. What is the name of this shape? You know what floored me, though? None of them knew. None of them buzzed in. You guys know, right? Please tell me you know. Okay, thank you. See? You need to know these things so you can win money on Jeopardy. Anyway, I digress. Let's go back to volume by cross sections. So now, do you recall, just kind of in general, we had a formula for volume by cross sections? The thing is so good. Very good. I'll give you a hint. Ooh, nice. I mean, I was going to tell you there was an integral in it, but yeah, you get the whole thing. Well done. So yeah, in general, area for cross sections is always integral of the area of the cross section, whether it's a dx or a dy problem. And then your limits of integration, remember, will always be wherever the shaded region goes. So all you have to do is find the formula for the area of the cross-section. And the cross-sections are squares. What's the formula for the area of a square? Yes. Area is equal to s squared. So what in this picture will be s? The height thing? Yes, the height thing. I love these technical terms. This is good. So what is the height thing? Yeah, it's top minus bottom, which will be f of x minus g of x. Well done. So if we just plug it into our formula, then we can't really do anything else with it except just say that a of x is f of x minus g of x squared. Because remember, it's side squared. And voila. That would be it. So that is volume by cross sections. It's really not much harder than it is to find whatever the formula for area is. Well, sometimes it's hard to integrate, but that goes true with all. As far as setting it up, it's all about finding the formula for the area of a cross section. Any questions about cross sections? Because then let us look at discs. Discs, washers, and shells. Lions and tigers and bears. Oh my. We're going to look at all three of these together. Oh man, I'm still in the rectangle. So there is a little something. I don't know if anybody noticed this. I actually don't know if it showed up in any of your problems on the homework. But just in case. With this, it's typically with discs and washers, but I suppose it could happen in shells. You know how with cross sections, we said you knew it was going to be a volume by cross sections because it's going to mention the word cross section. But the problem could mention the word cross section and it actually be discs and washers instead. Because if you think of a cross section by volume, like we can still talk about cross sections is the point. Your cross section is either going to be a disc or a washer. So does anybody know, like, if these did mention the word cross section, what's going to be different about these problems than the actual cross-section problem? Like, how do we know we're not going to use cross-sections here? Malika? No, it'll just say the cross-sections drawn perpendicular to the x-axis are blank. So, rotated around something. That's the key. So, just a little thing to beware of. Beware! Warning! Warning, Will Robinson. Danger, Will Robinson is how it goes out. Anyway, beware. These problems might mention cross sections, but they will also mention something about an axis of rotation. So just beware. So I'm going to draw a figure, and we're going to rotate it. I don't know. I'm going to draw it twice. One of them is going to be set up nicely for discs or washers. The other one is going to be set up nicely for shells. I won't say which is which. I'm basically going to draw that same region we had above.
So there's y equals f of x. There's y equals g of x. And from A to B. Now let's not use the same color. So just draw this twice. Oh, I always want to do that. All right. I don't know. Somebody say X or Y. Okay, X I heard first. So I'm going to say, oops, that's not the X-axis though. Let's rotate this first picture by the X-axis. We're going to rotate the second picture by the Y-axis. So if I am going, I have my choice. I can use discs, washers, or shells. Let's look at the first picture. So think about it. I did have to. Wow, I don't know my x-axis and y-axis. Oh well, I guess we're going to rotate about the y-axis on the first picture. I don't know where my brain is today. Anyway, so we're going to rotate the first picture by the y-axis. Don't say anything out loud, but think to yourself. Would this be easier done by discs, washers, or shells? And I'm going to put discs and washers together. We'll say discs, washers, shells. Think you got it in your head what it might be? So what I want you to do is give me a thumbs up if you think it's discs or washers. Give me a thumbs down if you think it's shells. And go ahead and give me a sideways thumb if you're like, I'm not sure. So disc washers up, shells down, sideways down. Well, the good news is I don't see anybody saying disc or washers. We seem to be pretty much 50-50 on I don't know versus shells. Shells it is. So, well done there. So can we help the people that weren't sure? Why did you guys use shells? Because you are correct. Shells is going to be the better method. Sophia? How do you know a shell has to be a dx problem in this case? That's what I was looking. Why perpendicular to the x-axis? Well, okay, so first of all, if you're going to draw a rectangle, let's look at horizontal, because, yeah, horizontal doesn't make much sense in this case. Should have drawn the picture more exaggerated. But, like, depending on where you draw the rectangle horizontally, it's not always the same function on the right and left. If you draw it horizontally, you'd have to think right minus left. And it's kind of going down a little bit and then coming back up. So there'd be a little part where right minus left would be green minus green. But then it is vertical line minus green, vertical line minus green, vertical line minus green. But then you get up here, and then it's vertical line minus pink and pink minus green. Like there's wonkiness going on. Right minus left is going to cause us problems. So, yeah, let's not do it that way. It does make more sense to draw the rectangle vertically in this case. Because then, no matter where you draw it, you could draw that rectangle anywhere vertically. And top minus bottom is always going to be pink minus green. So that's good. And then the other thing, because it's a dx problem, if you draw your rectangle vertically, then you need the equations written in terms of x, which they already are. They're already solved for y. So like it's just It's screaming, draw the rectangle vertically. So any questions about why the rectangle going vertically is a better choice than horizontally? And then, don't look at the x-axis instead, look at the axis of rotation. The rectangle is parallel to the axis of rotation. And when it's parallel to the axis of rotation, it's going to make a shell. If your axis of rotation is horizontal and your rectangle is horizontal, it's going to make a shell going sideways. If it's vertical, it's going to make a shell going up and down. So, yep, that's going to be a shell problem. Shell. And then similarly, we still, for the rotating about the x-axis, for the same reasons we said before, drawing that rectangle vertically is going to be the better choice. But now you're rotating about the x-axis. Now your rectangle is perpendicular to your axis of rotation. So as it goes around, it's going to make a disc. Or a washer in this case, because you got a hole. So those are all things to think about. Think about your top minus bottom or right minus left. Which one is easier? Think about your equations. Are they easier solved for x, easier solved for y? Or maybe you have an equation that can't even be solved for one of the variables. Maybe you can solve it for x, but you can't even solve it for y, or vice versa. So it's all about the rectangle. Once you figure out which way to put your rectangle, that's going to tell you if it's a shell or a disc or washer. Any questions about that? Then what about for a shell? Do you remember the formula for a shell? Sophia? Yes, in this case dx. Yeah, be it dx or dy. And then remember, as far as in the picture, where to put these things? Excuse me. P will be measured from the axis of rotation to the shell. And then H is the height of the shell, height of the rectangle. Anybody remember the formula if we're going to do the washer problem then? Go ahead, Sophia. Yes, excellent. And then remember your big R gets measured from the axis of rotation to the furthest part of the rectangle, and your little r is from the axis of rotation to the closer part of the rectangle. And then after that, it just depends on what integral you got. So any questions about that? All right, that pretty much ends the review. I'm going to go ahead and